Okay, so in this video, let's talk about the mechanism of this particular reaction. So this is a most famous reaction, especially in question papers. Let's look at it. First of all, we have osmium oxide. Here the structure is like this. Now, in the first step, what happens is we have the alkene structure. Now, what happens is the bond breaking and bond forming reaction will be happen simultaneously, which this electron pair will donate electron density towards this particular oxygen, and due to this bond will be broken, and this bond will go and form a bond with this particular carbon. So we will have our product like this. We have a double bond here, and now we have formed a new bond here, another bond here. We have osmium here, oxygen, and oxygen here. Now we have water in our medium, right? So one of the lone pairs in our water will go and attack to our osmium, right? Due to this, one of the bonds of these two oxygens, either this one or this one, will be broken, and we will have our product like this. Here we have the alkene structure, and we have two oxygens. We have osmium, double bond O, one oxygen. Now it has a negative charge, and we have OH2, right? Now this oxygen here, it has a lone pair. It will come again to form a new pi bond again with osmium. So now you know this osmium is getting destabilized. In order to get stabilized, it has to break one of its bond. So in this case, what happens is this bond getting broken. To this case, we have our product like this. We have two double bonds. We have H2O molecule here. We have this negatively charged oxygen atom. Now a protonation happen, like protonation means the hydrogen transfer. This hydrogen will be transferred into here. So this positive charge will be diminished, and also along with this negative charge, we have the product like this. Okay, now again what happens is another H2O molecule is there. It will go and attack to osmium here. Due to this attack, one of the double bonds with the oxygen, either this one or this one, will be broken. We have our again just like this here, right? Just like the same. Here we have oxygen, OH, osmium here. We have newly formed bond between the water molecule, and broken bond here with the negatively charged oxygen atom. Here we have the structure, right? Now what happens is this lone pair will come back to form a double bond between osmium, and due to that, the osmium and osmium atom need to break one of its bond. So this bond will be broken. So I will draw the new structure here. We have OH2, positive charge. Sorry, this bond is broken, right? Now this bond is broken. We have negative charge here, and here we have a OH. We have osmium, and with OH2, two oxygens, and OH. So this is a positive charge. Now again, just like before, this one of the hydrogen will be transferred to here. We will have a product like this. These are our products. Okay, now another important thing to notice here is this product. Okay, always this come up with the syn addition, right? This syn addition, which means like both of these hydroxide groups, right? Both of these hydroxide groups in the same plane. Like if this is out of the plane, then this is also coming out of the plane. If this is into the plane, this is also coming into the plane, like this. This never changes. We call this like in the same direction, in the same side. If your two hydroxyl groups are in the same side, then we call it as a syn addition. If it's in the opposite side, I mean like this is out of the plane and this is into the plane, then we call it as anti-addition. So this reaction always give the syn addition products. That's a very important thing to notice. Like some of the question you may ask to draw the stereochemistry. So in those cases, you need to draw the stereochemistry perfectly, right? If you draw two products with one with the both in the same plane and other one is the opposite plane, it's completely wrong. In this case, it's either onto the plane or into the plane, right? So either one, both are the same. I hope it's okay. Now this product here, this can hydrolyze, like it can leave one of the H2O molecules to form this guy, right? So one of the major things in this reaction is when it comes to the commercial usage, right? This osmium oxide, this guy, okay? This is very toxic. This is not very toxic, but it's considerably toxic and also volatile and so much expensive. So it's really hard to waste this compound more and more for the reaction. So what we can use is another compound which we use as NMO, right? The name is like N-methyl methylene N-oxide, right? This guy can oxidize this osmium atom back into the original form. So we don't have to re-adding our reagents like osmium oxide. We don't have to re-add into the mixture, like it will self recycle into the original form. So it's a major advantage when it comes to commercial usage. So otherwise, when it comes to the chemical mechanism, this has no impactful effect. So these are the common things which we need to know. Otherwise, like you can use KMnO4 also, right? If you look at the KMnO4, here we have the structure, right? Okay, so here we have the MnO4, here we have the negatively charged. Okay, so here we have the O. So here we have the MnO4 minus structure, right? This is the MnO4 minus structure. This just the same mechanism. It's not a big deal. Like it's just the same mechanism, just like here. Just imagine this structure for here. Just like the same. First, we are going to add this MnO4 minus into the ring structure, and then the H2O molecules comes to attack it, and then again one of the groups will be removed. Again, H2O molecule will come and attack it. It's the same. So mostly when it comes to organic chemistry, when it comes to practical usage, we use KMnO4 because it's easy to find and also it's effective. I hope it's fine with the mechanism. This is a very useful mechanism. Just understand, right? It's not a big you may see it has many steps, but it's not a big deal, right? You may see like after this particular scenario, it's just the same thing repeating, right? So it's completely fine with it. Just understand the reaction, understand the logical part in this reaction, so you will be fine. If you have any question, feel free to comment below.